Understood. Period 1. So here's the equation of the unit circle. If you ever wanted to graph the unit circle, I don't know why you'd want to do that, but if you did, this is the equation that graphs it. Sine squared theta plus cos squared theta equals 1. Yeah. Except your calculators can't graph circles. They're not smart enough. What the heck is this? Where does this come from? Well, you don't actually need to know where it comes from, but you know me, I like to tell you the why. Don't write this down, just follow my logic here. Here's a really big unit circle. Unit egg, let's pretend it's a unit circle. And I can take any point on the unit circle, and this is how we started this unit, saying any xy value. And I go do, 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 and I make this right angle triangle, remember this? And this is y, and this is x. And what do we know now about x? It's the same as cos. And what do we know about y? It's the same as sine. And because this is a unit circle, what do we know about the hypotenuse? It's 1. And Pythagorean theorem says that x squared plus y squared equals 1, which means cos squared plus sine squared equals? It's just a Pythagorean theorem. That's all that is. Grab our cue cards. We're going to go to the back of the cue card, and we're going to write down this first formula, sine squared plus cos squared equals 1. The second blue sheet on my wall that's now taped up, thanks to Simon this morning, the very first formula, sine squared plus cos squared equals 1. So there it is. It's not hidden. It's on your formula sheet. It'll be there. It's a really important formula we're going to use for the rest of this unit and all of Unit 2. Well, let's just isolate sine squared. Why? I'll tell you later, but let's just get that sine squared by itself. So if I want sine squared by itself, what do I need to do with the plus cos squared? I just need to subtract it off. So I get sine squared equals 1 minus cos squared. Same formula, I just moved stuff to the other side. I didn't change the formula. Let's add that to our cue card, and there's a reason I'm doing it in a different color. Not on the formula sheet, not on the blue sheet, because it's the same formula. We just took the cos squared over, and I'll show you why once we start to do the examples. Okay, well, let's go back to the original, and this time, instead of isolating sine squared, let's isolate cos squared. Let's get this cos squared by itself. So what do I need to do with sine squared? Subtract it over. So I'm going to get cos squared equals 1 minus sine squared. Again, same formula, just looks a little different. Let's add that to our cue card. Well, let's go back to the original, and let's divide every side or every equation, part of the equation, by sine squared. Why? Because I can, and mathematicians like doing stuff because we can, because we want to know what's going to happen. So I'm going to take the original, sine squared theta plus cos squared theta equals 1, and I'm going to divide everything by sine squared. And so the first term is fairly easy because it's sine squared divided by itself. And what's anything divided by itself? 1. So that's kind of handy. Cos squared divided by sine squared. Well, let's ignore those squareds for a second. And there's something we've talked about that is cos theta over sine theta. So flip over your card. What have we talked about that is cos theta over sine theta? Cotan. Well, all of the formulas on the first side work with squareds. So for example, if I have cosecant squared, that's 1 over sine squared. If I have secant squared, that's 1 over cos squared. So anything on this side will work if I square it. So I can say that cos squared divided by sine squared is cotan squared. One over sine squared, again, just ignore that squared for a second. 1 over sine, 1 over sine, oh, cosecant. So 1 over sine squared has to be cosecant squared. Oh, that's kind of cute. So let's write that on our card. And I'm going to go back to my first color. 1 plus cotangent squared is cosecant squared. And let's just say that I want to isolate cotan. So for some reason, I want that cotan by itself. What would I do with the 1? I would subtract it. So the other side would turn out to be cosecant squared minus 1. Again, these are all the same formula. I'm just using some math to make them look different. But it all is just Pythagorean theorem. Comes from a squared plus b squared equals c squared. He was a smart guy. We're sorry we killed him. Okay, well, let's go back to the original. And this time, instead of dividing by sine squared, let's divide by cos squared. Why? Because we can. So dividing everything by cos squared. Sine squared over cos squared. Just ignore the squareds for a second. Sine theta over cos theta. Sine theta over cos theta. Oh, tan, okay. So sine squared over cos squared is equal to tan squared. And cos squared divided by cos squared, well, anything divided by itself, 1. That's kind of handy. 1 divided by cos squared, secant squared. Again, same formula. I just made it look pretty. Adding that one, we have tan squared plus 1 equals secant squared. And let's just say I might want this tan squared by itself. How would I get rid of that plus 1? Subtract, so the other side would end up equaling secant squared minus 1. Again, these are all the same formula. I just made it look different by doing some cool math. Look back up on the second blue sheet. You'll see the second and third formula on there are the other two. So the ones in red on this card will always be up there. They'll be on your formula sheet. The black ones are not because they're just the same formula. I'm just rearranging what's on each side. Questions so far? Let's go back to the first side. Remember I told you that all of these work if you square them. You might want to just make a note on this side of the card to remind yourself. So these work when squared, or however that makes sense to you. You can square both sides, and they are very true. So cotan squared is 1 over tan squared. Secant squared, 1 over cos squared. We can square both sides of an equation, and that's all good to go. Flipping to the back. The reverse is not true. We cannot drop the squares and say these are equal. So we know a squared equals b squared plus c squared. There is no rule that says a plus b equals c. So you cannot use these without the squareds. You might want to make yourself a note. These do not work without the squares. Do not work without the squares. Just repeating the first side, if you want to add squares, that's awesome. They will still work for you. This one, if you want to take away the squares, not going to work. These have to be squared in order to be true. What's the point of this? Why do we have all these new formulas? There's so many of them. They're big, complicated. Well, let's look at the examples. This card is now going to be your key, your little friend to solving all of these guys. So grab your paper, put a title on it. Turn and talk. I want you to tell your new friend what are the 5 steps to solving any trig equation. Turn and talk. Tell your friend what are the 5 steps to solving any trig equation. What is the first step in general for any trig equation? Isolate the trig function. What was step 2? Reference angle or the family. Step 3, quadrants, give the answer in the quadrant. Step 4, check the interval. Step 5, no interval means general statement. Those are going to be the exact same steps. I'm not going to change any of them. There are no exceptions. Those are the 5 steps for every single question. Isolate the trig function. The problem is which one? We have 2. So let me give you a question that you might have seen in grade 9 or grade 10. And if I said factor it, because it's got a squared, it's quadratic, factor it. So you would have taken everything onto one side, and then you would have stared blankly at the page. So what's the problem with factoring this? Can't. Why not? Andrew. Two different variables, right? There's no common factor. This isn't a squared plus b squared equals c. There's no way to factor it. That's how you're going to know when you come to this, you can't start with factoring. Even though it's a quadratic, there's 2 different variables, there's 2 different functions. This card is the key. You want to look for something, some kind of formula that connects secant and tan. So let's start on the first side that we had. Do any of these formulas have secant and tan in them together? Nothing on this side has a secant and tan, so let's flip it over. Do any of these connect a secant and a tan? Yes. Okay, these last one that we added. So what I want to do is I want to get one of these out, and I want to put the other side of the formula in. I have to use secant squared. I can't use tan because tan isn't squared, and these don't work without the squared. So I want secant squared out, so I want to find which of these has secant squared by itself. The first one. So I can take out secant squared and I can put in tan squared plus 1. So secant comes out, tan squared plus 1 goes in. Why? Because these are equal. Just from what I did with the Pythagorean theorem, changing it to the unit circle, dividing everything by sign, and making it look different. Those are equal expressions. This card will be the key. If it's not on the first side, there'll be a formula on the second side. Okay, well, what was the point of doing that? Well, now it's all tan, so now I can factor. So I'm going to take everything onto one side. This is the same as x squared minus 2x plus 1 equals 0. Nobody came in for factoring help this morning, so I'm assuming everyone's good to go. If you're like, but wait, I can't factor. Where are you going to be period 1 tomorrow? In resource with her, and she will show you how to factor. X and x, and minus 1, minus 1. Okay, so bring it back over here. The 2 binomials are going to be What do we do after we factor? Split and solve, Mr. Squiggs. I don't know why I do that, I just have to. So on the left, tan theta equals theta r quadrants theta offer of pi on 4 and 5 pi on 4. You have to memorize your unit circle and you need to know the tan values. The right-hand side, what do you notice? Do we need to solve it twice? No, it's going to give the exact same answer, so don't waste your time. We're only on step 3. That was the end of step 3. We still have step 4. What is step 4? Check the interval. What does this mean, 0 to 2 pi? Between 0 and 2 pi, so it means all 4 quadrants. Are these both between 0 and 2 pi? Final answers. Example 2. Okay, secant, cos, secant, cos, secant, cos. The minute you see more than one function, you know you're grabbing this card. I always start on the first side. I don't know why. I just like this side first. Is there any form on this side that links secant to cos? Secant is?
1 over cos.
Okay. So do you want to move it to cos or do you want to move cos to secant? Because we could do either. So do you want to change secant to cos or cos to secant? Why do you want to do secant to cos? Oh, you want to do cos to secant, okay. They'll both get us in the same spot. Which is the easier solution to pick? Get secant out because we've memorized sine, cos, and tan, so it's just going to be less work later on. So I'm going to keep that 3 in front. I'm not touching them yet. I'm going to bracket the substitution. Secant is 1 over cos. And I'm not touching the right-hand side. Just to repeat, that was not our only choice. We absolutely could have turned cos to 1 over secant. It just means in the end you're going to have to flip to do a reciprocal. And if you're fine with that, there's nothing wrong with that. Okay, multiplication of fractions. How do we multiply fractions? Top by top and bottom by bottom. And what happens here is somebody always does 3 times 1 and 3 times cos. That's a really, really common solution. But you need to understand what's on the bottom of the 3 that we don't see. Imaginary 1. So top times top is the 3. The bottom is 1 times cos, which is cos. Okay, I don't like this cos on the bottom here, so I want to get rid of it first. What's the opposite of dividing something by cos? Multiplying. So I'm going to multiply both sides by cos. So on the left they cancel, because that's what I wanted to have happen. That's why I did it. And here I just need to multiply a cos times a cos, cos squared. And a cos times a minus 2, minus 2 cos. If your brain on this right-hand side was like, what? Just think of it like x times x minus 2. We did the exact same thing. X times x would be x squared. X times minus 2 is minus 2x. Okay, I'm down to one function. This is awesome. What do I want to do now? Now I want to factor. How do I know I want to factor? Because there's a squared. It's a quadratic. So I'm going to put the 0 on the left, move everything onto the right. Why did I choose to go to the right? Because usually we like stuff on the left. Why did I choose to go to the right? Everything's already on the right, and when we factor, we typically want this first term to be what? Positive. Otherwise, I got to deal with the negative, and I just don't want to deal with it. Okay, this is the same as x squared minus 2x minus 3. Cos plus 1, cos minus 3. What do we do after we factor? Split it. Cos theta equals minus 1. That's not a family value, that's an axis value. So you look, negative 1 over here. So theta has to equal pi. Cos theta equals 3. What did I do with that? We didn't memorize 3. Ooh, that would be the theta. We don't know what theta is. I like where you're going, but you're going down the wrong path. Okay, so inverse cos in our head, and we're right back to this. Inverse cos of 3. What do you know about cos? It can't be greater than 1. So this side's done. Can't solve it. It's done. Cross it out. Okay, so you might want to make yourself a note for sine and cos. If they're bigger than 1, just cross it out. Tan is a different story, but sine and cos can't be bigger than 1. Okay, sine and cos, if they're bigger than 1, you're done on that side. Not with tan. Tan, we'll do an example later. Still not done. We still got steps 4 and 5. What is step 4? Check the interval. Oh, crap. We had this one yesterday. What was the deal with this negative pi interval? Yeah, anything that's in 3 and 4, we have to do not the reciprocal, the coterminal. So you just want to make yourself a note if you didn't recognize that. This means coterminal. And so it means we need to take pi and do the negative coterminal. How do we do negative coterminal? We subtract 2 pi. So pi minus 2 pi. Negative pi. So our two answers are negative pi and pi. The only reason we have this negative pi was because of the interval up here. If this had been 0 to pi, we would have just left it. That's why Yoshi has been whispering at me, negative pi, for like the last 5 minutes. In case you heard him. How are we doing? Number 3. Look at all this stuff going on in number 3. If anyone did their homework last night and did some practice, you'll probably understand now what I mean when you look at the answer. You're like, yes, when you did all this work and you have the right answer. So satisfying. First thing your brain picks up on is there are 2 different functions. The minute there are 2 different functions, you're grabbing your card. There is a squared, so you're probably going to the back of your card. Is there any formula on here that links sine and cos squared? Yes, sir. And the reason we did these variations is just so it's easy to grab the cos squared now. So cos squared is going to come out. What's going to go in its place? 1 minus sine. That's the only reason we did the rearranges, just so it's a little bit easier in your head. I'm going to highlight for the visual people. Cos squared is coming out. Sine is staying. The negative 3/4 is staying. What is going in cos squared spot? 1 minus sine squared. I'm not loving the orange highlighter, actually. It's a little bloody. I don't like that. Why? Because of Pythagorean theorem, because a squared b squared equals c squared. That's why we can swap them in and out. Okay, I got a lot going on here. I don't like the fraction. So the first thing I want to do is get rid of the divided by 4. What's the opposite of dividing by 4? Multiplying. So I'm going to do sine squared times 4. I'm going to do 1 times 4. I'm going to do negative sine squared times 4. And I'm going to do negative 3/4 times 4. That doesn't have to be your first step. If you don't mind fractions, you can combine it with the 1 on the right-hand side. I just don't want to work with the fraction. Now I need to get everything onto one side because I've got this squared and I know I need to factor. Do I want to get everything on the left or onto the right? Okay. Toss up there. Yeah, I want to turn this positive. So if you bring to the left, that's fine. Then you can multiply through by -1. I'm going to take it over just so that squared is positive. So minus 4 sine squared is going to turn into 4 sine squared. A 4 sine is going to turn into a minus 4 sine. And then a minus 4 over here would give me minus 7. Again, you could have taken to the left and then divided by everything by -1 to make it positive. Okay, product is -28. Sum is -4. Factors of 28, 1 and 28. 2 and, 3 and, nothing, 4 and, 7, 5, 6, 7. Okay, so we've got all the factors. So what's the combination that's going to add or subtract to give me -4? Oh, people are like, Joe, what does this mean if we can't factor? Quadratic formula. X equals -b Okay, so x equals -b is -4, so 4. -4 squared, 16, minus 4 times -7. And on the bottom, I have 4 times 2. Four times 2, 8. Then I do the 4 times 7. I get that out of the way. So -4 times -4. 16 times 7. If you're panicking, that would be a calc question. So you could grab your calculator if you needed to. $112. Just a confirmation there. Then we'll add the 16 in right away. I'm just kind of hearing mumbles. 128. We're still doing okay? No, what are we not? Where are we not doing okay? What is negative? No, because it was -4 times -7. So there was a negative times negative there that gave us the positive. We can't cancel because there's nothing in front of here I can't cancel. So I could absolutely reduce. I'm not going to bother because I'm about to punch this into my calculator anyway. So reducing isn't going to get you any further. If this was a final answer, yes, I would. But here it's not. I just want to make sure we're good with where all this came from. Okay, so what does this mean over here? Well, this is now splitting into two solutions. So sine theta is 4 plus root 128 over 8. And sine theta is 1 minus root 128 over 8. Which, by the way, Brazilians never factor. They always do quad formula. Because why would you factor when sometimes it doesn't work? They always go to this right away. Yay, Brazilians! You guys are like, oh no, quad formula, I hate you. Okay, what do we do with this? Well, let's just get the decimal value of whatever this stuff is, and I don't want you to round it off. So just put into your calculator 4 plus root 128 divided by 8. Let's make sure we all have the same number. Don't round it off. I'm hoping it's a 0 point something. No, okay. 1.91. I don't want you to round. Give me a whole bunch of decimals. And I'm just going to put dot, dot, dot to show that I'm not rounding yet. Confirmation?
This number just leaves it in. I could just leaves it in the variables.
And that's fine. That just means you have a really smart calculator. And let's do the same on this side. So again, don't punch it all in. Recall your last entry. Have you seen that before? Go second function, enter, which should have the word entry. And you can keep doing that, by the way. It will recall the last 25 things you typed, one of the smartest things the calculator does. So you can just recall this, tab over, and change this to a subtract. Minus 0.914, dot, 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 dot. If you've never seen that entry before, you'll love it, because you don't have to type everything in again.
Negative 0 point a whole pile.
Confirm. No confirm.
Negative 0 is confirmed.
Oh, shame on you. Okay, let's go back to the left. Now we need to do reference angle. How do we get the calculator to give us a reference angle? So how do I get rid of sine? How do I take sine over to this side? We talked about this yesterday. Inverse sine. So inverse sine, 1 point, oh, whoa, whoa, 1 point what now? What do you know about sine being bigger than 1? Done. We love when sine is bigger than 1 because we get to cross it out. We're like, yes. This one we're going to have to do some work. Now remember, the reference angle is not including the negative. Do not include the negative. Don't round this off. Put as many decimals as you see, because if you round here, your final answer will be off. So inverse sine 0.914, blah, 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 hit enter. Can't be negative, because you didn't include the negative. Sorry, 1.153 dot, dot, dot. Now your brain might be going, whoa, that seems really, really tiny. But remember, we're not working in degrees. What are we working in? Rads. And the first quadrant is from 0 rads to pi over 2, and pi over 2 is 1.57. So if you're between 0 and 1.57, that's a valid answer here. Why did we not include this negative? Because that's just a quadrant reference, and this is telling you what quadrant.
3 and 4.
Okay, how do I get the answer in Q3? Pi plus the reference angle. And now you can round because we're at the end, so 3 decimal places, unless the question says otherwise. Probably 3 something, 3 point something. .4.295. 4.295. That sounds confirmed. Okay. How do we get it in Q4? 2 pi minus the reference angle. Probably 6 point something something. .130. That sounds confirmed. Oh, but wait, we're not done. We're only on step 3. What is step 4?
Interval
Okay.
of
Oh, whoa, okay, there is none. Whoa, step 5
General solution.
plus 2 pi k E z. This is as hard as these equations are going to get.
With the quadratic formula and the general solution.
I know. I feel like it's a good time to stop, and we'll do the other set of the other 3 examples this afternoon.
I can put a question and do the first thing.
I know, but how much fun is that?